All righty, welcome back everyone to day 2. That is session 2 of 3, Cybersecurity with Python and the Microbit version 2.0. With you today are me, Stephanie Lindsay, but not Ari today. He couldn't make it. So yesterday we kind of did some microbit basics and then went over the computer science portion of the cybersecurity curriculum. Today we will focus on the cybersecurity portion and then finish that up on Friday with malformed packets and defenses. Let's see here. This will probably be swapped around. The CyberBot robot demos will probably come after Chuck Gardner from cyber.org speaks about their offerings. And I think you'll find what they have to offer to be very useful and great for mixing and matching with many of the things we're going over here during these three workshop sessions. All right, now before I dive in, guess first of all, we'd better hit the questions and answers. Is anything on your mind before we move on to today? Okay, if not, go ahead and feel free to chat me or unmute and just speak up as to whatever your question might be. Now, I would like to review and emphasize a couple of things. Starting with slide 2, which is for attending this workshop, we want to have our Zoom view mode out of full screen. So let's see here. You probably can't see what I'm telling you about yet because I don't have the screen shared. Let's see here. So there's share screen. Okay. There we go. All right, so the first thing I'd like to talk about is having your Zoom window side by side with your Chrome browser with some Python editors open. I should also go ahead and just repeat the slideshow link in case you want to grab anything or follow any of the links you saw me follow out of the slideshow. So this is coming at you over the chat. Then again, when the Zoom meeting is filling your whole window, as it probably did when I switched to presenter mode, up in the upper right corner, there will be a view button. And when you click it, you can exit full screen. Then you can resize the screen to only fill a portion of your screen or possibly move it to a different screen if you have more than one monitor. Then on the other side, we want to go through the setup of getting into python.microbit.org/v/2 editors. So 2 tabs of those, and then we'll be connecting our microbit to each of those tabs. So what I will do is off on another screen here, go ahead and start a new tab. All right, so this would be your Zoom meeting. I'll just go to learn.parallax.com on this and learn.parallax.com. Okay, and so this is where your Zoom meeting would be. And then over here, we'll go ahead and open a couple of python.microbit.org editors, and we want to go to /v/2. I accidentally went to /v/3. So when it offers you the new Python editor, for now, just click the X to get out of that screen, or you can say not now. There's a button for that as well. And then once you've got one editor instance, go ahead and right click, select duplicate. Then you'll have another instance. And here's that not now button I was mentioning. Either the X or the not now will do the same thing for you. Okay, once you've got two Python editors open, go ahead and connect your microbits. So right now, if you look in the thumbnail, I have my pair of microbits. And on the other end, they're both connected to USB cables. And on the other end, I now need to plug those into my computer. For some of you, you might see Finder window if you have a Mac, or a Files Explorer window if you have a Windows machine, or a Files app if you have a Chromebook. And you can just close those for now.
We did have a question related to Chromebook.
Oh, thank you. What is the question?
On a side note, I was trying this one on one of my Chromebooks to get the feel of student, I'm assuming student experience. I could not get the microbits to register. It said something about a hex download. Was there something I had to download in addition?
Could not get it to register a hex download. Possibly. Okay, so let's see here. Generally, what that sounds like to me is needing to click the connect button first. I may be, misunderstanding the symptoms you're observing. So that just off the top of my head, I would say that without hitting the connect button, when you download something, it shows up as a hex file, microbit program.hex. Now, if you connect and select a microbit and connect, then you can flash it, and that loads the script. Here it is in my thumbnail in the upper right. So you can download or you can flash the script into the microbit. Then when you're trying to open that, you can click load save, select or browse for file. And then I'm selecting a different hex file from here. And when I open it, it shows me the hex file that I selected from my downloads. And you can actually browse to you should be able to browse to any folder you have, and even a flash drive on your Chromebook to get to a saved hex file. If you need to save a hex file, hit load save, download project hex, and then you'll have it in your downloads, and you can also move it and stash it somewhere else. The thing that might not be working, so here is microbit program.hex that I saved. If you drag that onto just a plain old editor, or I'm sorry, a plain old Chrome tab, what it'll show you is the contents of the hex file, which is basically a bunch of hexadecimal numbers counting 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, A, B, C, D, E, F. And so that's what makes up a hex file. But hopefully, if you instead drag and drop that hex file onto a microbit editor, it'll open whatever the hex file stores. If it doesn't, try load save, and then or browse for file, and find what you want and open it. Hopefully that'll help you out. I can also let us know if you're on the Chromebook today, or if you have the Chromebook nearby. We can definitely talk after the session if that doesn't answer the question. And let's see, we can also set up a brief Zoom meeting sometime tomorrow or even Friday morning to see what's going on with the Chromebook. Every once in a while there's a setting, and also there's a certain vintage of the Chrome browser that you know how Chrome updates its browser. There's a certain vintage of the Chrome browser that that was only available for a short while because they discovered a bug that affected the microbit and connecting the microbit to the browser. And so if you happen to have that version of Chrome, it's I don't know, maybe 4 or 5 months old now, that would also cause trouble, but not the message I heard.
Follow up on here is, I will try that later. Thank you. Okay, it would not be an issue if I had to use a USB splitter for that Chromebook. I am not on a Chromebook today. I hadn't considered a USB splitter in the mix.
Yeah, so some USB splitters work okay, and they'll actually split the power delivered to the microcontroller. Every once in a while, you'll still see a USB splitter that either has to be plugged into the wall to have power. So USB splitters don't always work. So if you have trouble with your Chromebook and using a microbit with a USB splitter, the first suspect will be the USB splitter. So we'll start with just one USB port. And then another thing is, if you want to let the hex files you download accumulate in downloads, then maybe when you're done with your session, if you want to copy them over to a USB flash drive, you can unplug your microbit if you only have one port, and then plug in the flash drive and copy the files over. Okay. Oh, cool. Okay, thank you, Anne. Sounds good. All right. Let's see here. So while I'm here, let's talk a little bit about the student experience and about some things to recommend to the student. So if they are doing, say, the cybersecurity tutorial, let's see. Where did cybersecurity go? Here it is. Boom. And let's say they're in the just getting started on the writing microbit programs, and maybe they're in the solve math problems portion of writing microbit programs. One of the things that I encourage everybody to do when they are learning a new language is pretty much the opposite of what I've been doing to show all of you. So, and that is that myself and you all included. The best way to learn a programming language that's new to you is to actually start with your example script, either on a printout beside you on another screen or side by side like this, and actually just start typing in everything. It takes much longer, yes, but this is it helps students memorize the syntax. It's going to help them because they're going more slowly and looking at each line and having it go in their eyes and out their fingertips. It allows for a little bit more time to think about each statement that they're seeing, because especially in these beginning tutorials, each statement has a lot of weight to it. It's things that are very important to learn about. And so by actually hand typing in each line, students can learn a lot, one, and two, they can also have experiences with making syntax errors. And instead of display.scroll, for the sake of just demoing it to you, I'm going to I'm going to substitute print for display.scroll here. So print A plus B equals comma C. Okay, so I took a few liberties there, but basically the idea is that in thinking about and going through, there's questions will come up, they'll think about things, and they'll make syntax errors so that when they try to flash it in, they'll get one of those, which one is it? Oh, that's right. We're not displaying it, we're doing it over in the serial. So they might be surprised by this. Apparently the plus operator does something that I'm not aware of with variables. So I don't know why it did that. I was trying to create a syntax error. My word. Okay, well, let's do something else. How about PRI, and maybe the O was accidentally pressed because the student was typing rapidly. And if we flash that, I'll have to look up what the multiple pluses do in Python. I'm sorry, I don't know that off the top of my head. But now we have a syntax error. And basically, on the microbit, it's displaying very slowly and meticulously what that error is. And just as a pro tip, anytime you're seeing this error on your microbit, here, I'll restart it so you can see it from the beginning. It's a frowny face. And then it'll start saying what line it thinks it found the error on. And it found it on line 7. And then it's trying to tell us what kind of error it is, but it's sort of hard to follow along with the scrolling characters. So instead, if you want to find out what it's trying to say to you, you can always hit the open serial button and see what the results are. And so it's telling us that there's a problem on line 7 with invalid syntax. So if we close the serial and go back to line 7, oh, so I have more than one syntax error in here now. So if we flash it and hit open serial again, now it's concerned with line 9 and it doesn't recognize the misspelled print. And so then we'll go ahead and hopefully fix everything. And so, see that this in and of itself is a very valuable experience for the students, so that they can see that they have to go and find their syntax errors when they're writing their own script. And why am I seeing that 131 still? Oh yeah, that is the right answer. Okay. Yeah, and in my mind, I had a couple of different values that were here. Okay, so this is definitely the recommended way to have students do it. If they're not doing that, definitely up the ante of the various challenges by encouraging them as homework or quizzes or whatever you want to try the your turns, because then they will at least have to put their hands on the keyboard in many cases and make some changes to an existing working script. Okay, so next up is slide 10, 11, and 12. So I just wanted to mention that on Monday, we talked about how microbit.org has some great icebreaker and beginner light and fun material, great for enthusiasm. And it's pretty cool to see all the things the microbit can do as well. And then that I have a YouTube video. It's a 2-hour. This first of the two is probably where you'll see the most information. So here's a 2-hour video on many of the resources you can find at python.microbit.org. There's a wealth of stuff that you can pick from, things that you might see that you want your students to try. And then last but not least, that by and large, the microbit.org stuff is targeted towards middle school. Cyber.org has material for both middle and high school that we'll talk about on Friday. And then Parallax is much more into the high school. It's not like we don't start from the beginning in the tutorials, but it does have a higher ceiling. Next up is slide 22. And oh yeah, actually we already looked at how to use load save and then or browse for file to open and download project hex to save. On slide 28, just a reminder that if you need some help with a term that you see in a script, you can click help and select documentation and then do a search. And I think what we searched for last time was sleep. And it wasn't really the first thing that we saw, but scrolling down, microbit.sleep. So it's the microbit module. That's this. And inside the microbit module is the sleep statement. And so once you find a likely candidate for what might have your answer, you can go ahead and follow the link. And sure enough, here it explains how sleep works. We also talked about objects and their methods like display.scroll and display.show. We talked about objects that they have properties like image.heart, and then that and those are all part of the microbit module. And modules also, in addition to objects, they sometimes have functions. In this case, sleep is an example of a function, and they sometimes functions accept arguments. We talked briefly about lists and tuples, and we even did a nice little musical application that accepted a list as, so you can give it just this giant list and then it parses through the list for you. So lists can be very useful. Okay, 35. And 48 was the last one of the previous slides. All right, so here on slide 48, this was some optional homework, but I'm actually going to go and just talk a little bit about these briefly because we went very quickly through it, and a lot of this is going to be used today. So for example, dictionaries will be used to put data together and transmit it between one microbit and the other. And so, so just a reminder that if you see a dictionary, it's a thing that's enclosed in curly braces, and it has key value pairs, and the key is separated from the value with a colon. And then each key value pair is separated from the next one with a comma. And that you can ask for a value that corresponds to a key and store it in a variable, or you can say, hey, find this key and change its value to this new thing. So that is dictionaries, and there's a whole chapter on it. And I'm just bringing it up. I don't think that we need to really, dwell too much on it. I'm just going to show you that certain things are there. I want to go through exceptions and exception handling again very quickly. So the minimal exception handling is basically if you have some code that you think might fail under some circumstances, you can put it below and indented from the word try. And then instead of having your script stop executing and telling you about an error on the LED matrix, you can add some statements that deal with the exception in one way or another. I'll get back to that in just a second. So the first script that I want to try today is just simply one. We'll do both versions. We'll do this working version, and then we'll also try out the version that is broken. So here is the script, and it should work. So if you go ahead, I pasted that into your chat, and if you go ahead and paste it into your microbit and flash it, and then hit open serial, you'll see that it successfully performed a division calculation. And then encourages you to try again, possibly adjusting the numbers a little bit. And let's see here. Next up, what I'd like to do is let's add an error here by making denominator 0 and flash it again. And the first thing that you'll see is that the microbit got stuck, stopped, and told us that on line 12, it ran into a problem, but it's hard to tell. So again, we'll go and hit open serial to find out what really happened. And it was a 0 division error. All right, so it told us, but it stopped working. Now, what we can do to fix that, try that yourself, by the way. And so we go through this step by step with little check marks for each step in the tutorial, and then we explain it in detail. And then in the try this session, so there's a script, some tests. It explains how it works. Then we get to something the students can try. Now, in this case, instead of asking the students to put their hand on the keyboard, since there's a lot here, I instead of a screen capture, we are just using more script. And let's see, I'll paste this into you all. And in this script, what we did was we put the statements that could fail into a try block. And then this is the syntax that's used if you want to capture the exception and plop it into a variable. Then we can actually print that variable and even determine the type of exception and print its type. And this is something that developers do as they're basically hardening their application. Oftentimes of interest. Oftentimes the type of exception will be of interest because you can prompt the user or the machine that's trying to have you do something to correct some kind of error or mistake. Now, this code is what is done if there's an exception. There's an optional else and an optional finally, and the else is basically if there's not an exception, you can add statements here. So you can say, well, if there is an exception, do these things under the except. If there's not an exception, do these things. And then finally is anything you might want to do regardless of whether there was an exception or not. And so that last little line of try again fits nicely here. And so if we do this, one thing you can do is change that D to 0 and try it. And you can also try making it a string. the number 4. Okay, if you try that and flash it. That didn't have anything to do with, said to disconnect and reconnect my microbit. Okay, let's try it now. Flash. Okay, so doesn't look like I have any frowny face and error messages. So let's go and look at the terminal. And what it's showing us here, I'll close and reopen this. What it's showing us here is that there was an exception because, and it tells us the message. And then it also tells us that it was a type error. And then it finishes off the script saying, try again. So I want to emphasize that it did not get stuck with having this not be a number in the denominator. It displayed the exception and then it jumped to, hey, here's what you do, or here's what to do after displaying the exception. And then if you use 0 instead, you'll get a different error. This time you get a 0 division error. And the reason I'm pointing this out is because what the students do next in the Your Turn section is they're prompted to take the part that was primarily diagnostic, that told us about the exception, and to try again. And we had them study, I kind of skipped over it, but they were prompted to study this 0 division and type error. And so you can actually modify your code so that it says, oh, well, if it's the 0 division error, just tell the user can't divide by 0. If there's a type error, tell them expected a number. And so what we can do in modifying this script is, instead of having the diagnostic part for development, we can switch over to something that would be more along the lines of what's needed for deployment. I'll paste this into you in just a sec. Copy, paste. Probably should have run it before I pasted it into you. Let's hope for the best. Okay, so here's our helpful hint, and it says try again, which means that it did not get stuck when you tried to divide by 0. It made it all the way to the end of the program. And you can also simply put this into a loop and ask the user for numbers and that kind of stuff. We did that with the countdown application. Next up is, so that's the user-friendly hints. Now let's talk briefly about strings and characters again. This is, by the way, these things I'm talking about, the exception handling, the strings and characters, and the dictionaries are very central to the cybersecurity stuff. So I'm just kind of doing a quick reminder about it. A string can be in single quotes. It can be in double quotes. It can have multiple lines if you use 3 single quotes or 3 double quotes. And you can also make a long string by using a backslash to join 1 or 2 or more strings. And if you want to show single quotes inside double quotes, you can do it with the apostrophe. There are also backslash characters that you can use, like the tab and the apostrophe, and you could even do backslash double quote if you needed to show it inside a message. And you can take a string I'm kind of summarizing an entire chapter here, by the way. You can take a string and put it into a variable and then do stuff like print that variable. I want to mention ASCII codes. ASCII codes are codes that correspond to characters. And so here we show what ASCII stands for. ASCII stands for American Standard for Code Information Exchange, And here is the list of ASCII codes. So I'd like to bring your attention that the code for the letter A is 65, and the code for the letter B is 66. And then the lowercase a starts up at 97, B would be 98, and so on and so forth. And so these are the codes that your keyboard sends to your computer using electrical and electronic forms of communication when you type keys. And I should actually say that modern keyboards send a little bit more information, I think, than just the number 98. Now, strings for exchanging data is really important, because what's going to happen is that for one microbit to send information to another, it's going to turn numbers into strings. And then the receiving microbit has to take that string and turn it back into a number. And so this is one of the activities that shows you how to do that. And I'll get back to this later on. I just wanted to mention that there is a tutorial about this. And then other things you can do with strings are various types of finding out what's in the string and surgeries. For example, here is a way to say, hey, what's the 6th character in the string named S? So we have hello string, we named it S. So you can say S of 6, 0, 1, 2, 3, 4, 5, 6, and you can find out that the character there is the letter S, and when you print it, it'll print out S. I mentioned ASCII characters earlier. You can ask what that numeric code of a particular character is using ORD. You can take that numeric code and convert it to a character using CHR. You can also ask for the length of a string, and you can also take something like an integer and make it a string by putting it inside str. So this is actually the inverse of it right here. So here we have S, which is the string 1, 2, 3. And if you say int of S, it gives you back the number 123. Once you've got it as a number, then you can add to it. And there's a whole lot of other stuff that you can do with strings, and including find the word sequence. It's right here, but how does a computer do that? You can replace stuff. You can turn it into a list of characters. You can make them all upper and lowercase, and these all have different uses and applications. And so to that end, I think looking on the next slide here, oh, no. Where did I put it? Okay. Is it here? I believe it is. So, or maybe here. So what this is we were looking just now at these various features. No, yeah. So we were looking at these. And so one of the challenges that comes up in the chapters is to display the results of those things. And so the challenge here is to take the hint of how you would display with print and display the results of all of those features. Keep on closing that tab, sorry about that. All of these features to try them out in a script. And so what I wanted to have you do is try those out, or actually I think I'll just demo them real quick. I'll paste it in case you want to try them out, but it's not okay. So what I did was I modified this not only to use print, but also to use the input statement so we could look at them one at a time. So here that comes over your chat. One more try. Okay, that script is too long. I'm going to have to, let's see here. Let's try doing let's try pasting in just a little less and see if I can get it to you. Okay, so there is most of it, and then I'll just give you the tail end as well. Can also grab it out of slide 52 in the speaker notes. So I'll leave the code on one side and run it with 1 microbit. Okay, so first off, it says n equals 124. And what that was in response to saying that a string is the characters 1, 2, and 3 inside quotes, and then int of n or int of s spits out the decimal equivalent of that. We can add 1 to it to prove that now you can use it in arithmetic and then display the value, and you'll see 124. And you can press enter to continue. And this is just showing that a string here, we named it string, and this is what got copied into that variable, and then it got displayed using the print statement. Next up, it's asking for the index of this. And so remember that or basically if you count from 0 to the S in sequence, you'll find that sequence starts at the 27th character. Then this is where we did some string surgery by using the string.replace method to replace it with a string. And so now it says a string is a sequence, etc., instead of it is a sequence. And then next up, we can list all the characters using the list function. And then we can also make it all lowercase or all uppercase using string.lower and string.upper. And there was one more thing I wanted to show you, which is, we actually talked about it already. It was characters inside strings. No, actually we didn't. And this is a script that I really want you to try, because it shows in action how to say, hey, what does a character, what is the numerical value, the ASCII value of a character, and store it in a variable. And then we can display that. And then we can also say, okay, well, if I added 1 to that number, what character does that represent? And that's going to be very key when we get to encryption. So here is that script. And when we flash it, and then open serial, we'll see that it says, it prints the ASCII code for A, then asks the microbit, hey, what is the ASCII code of A, using the ORD function, and store it in N. And then it prints that value. And so we see that the ASCII value of capital A is 65. After adding 1 to 65, that's 66 down here. And then we can see that the character equivalent for that is B. So that's both, that's going both directions. That's saying, hey, what is the number that corresponds with A? And hey, what is the letter that corresponds with 66? And that concludes the discussion of the basis for the computer science basics that are gone through before getting into the cybersecurity lessons. Before I move on, do we have any questions, comments, points of interest? Okay, we'll be taking a break in about 10 minutes. Well, actually, yeah, let's get started on encryption, and then we'll take a break in about 10 minutes. Okay. So encryption is going to be very much related to strings. Now, what we start with is a really basic example where, okay, well, the first thing that every chapter starts with is an overview. And so we talk about what encryption is about, why it's important, also what you need before you start in terms of hardware. This is at the beginning of every chapter. I just thought I'd mention this as a sideline. We also have a list of prerequisite tutorials. Essentially, if you haven't done these, you might feel kind of lost as you're going through the material at this point. Some of these tutorials will point back even further, and that's because we see some students who want to jump way ahead. And so we try to help folks understand that this is built up knowledge. And then some goals for after you finish. And then the first most simple example is something called the shift cipher, or well, it's a form of shift cipher called the Caesar cipher, attributed to Julius Caesar, who used it to keep written messages, to encrypt written messages, sending them to his generals and captains and etc. on the battlefield. So this is a pretty basic example where essentially we start with plain text That's what the text you're starting with is. That's the name for it. And so if we start with hello, encryption can have a key to encrypt and decrypt. And we arbitrarily chose a key of 5, although truth be told, it just made it much easier to illustrate this in the drawing. So with a key of 5, we have our H, which is the first character. And in a shift cipher, and particularly in the Caesar cipher, if your key is 5, all it means is that if you're starting with H, you count over 5 characters to get to M, and that's your ciphertext. Likewise, the E shifts over 5 and it becomes the letter J. And decryption simply goes in reverse. So if you start out with MJQQT, you can take a look at that M, and if you know the key is 5, simply subtract 5 from your character, move over 5 values in the other direction, and you'll get your H. And likewise, that J will give you the E in hello. Oh, gee, what happens if your key goes beyond the end of the alphabet? All is not lost. All you have to do is keep on counting letters after you wrap around to the other end. Okay. So the first thing that we can try for encryption is to what this script does is it starts you with an alphabet, and it uses we called it alpha instead of string or S. And so we can take this M letter here and find out where it is in the alphabet. And then we know, well, its number. And for encryption, you can actually use that. You can say, okay, well, if the letter M and the key is 5, you can again find the index of the letter inside our alphabet string here. And then if you know the key, you can find the index. Let's see. That's just printing the index, sorry. Here's the good part. Once you've found the index, then you can add the key to it. And do you remember that part where we were talking about wrapping around? Well, this is the trick to do that. I'll come back to that in a second, because we don't need to wrap around here. Now the result is another thing we talked about in the strings chapter was you can have a string and you can look at a particular character at a given index value. And so if we start with M and a key of 5, so this is our plain text, this is our ciphertext, and so 1, 2, 3, 4, 5. So R should be my encrypted letter. So let's all try this together. Copy. And paste it into your chat. Give me a shout out if I end up going too fast and you're unable to follow along. So we started with the letter M. It had an index of 12. We added a key of 5 to it. Our new index is 17, and we used the string find to find our new result, which is R. So So we have letter, which is M, alpha dot find of letter. I could have just stuck M in there, but this is building up towards something. So we start with M and find out it's the 12th character. Then we display the key and the letter at the index. And then we say, okay, well, index equals index plus key. And then this modulus operator right here, what this does is it says, okay, we're going to divide by 26 and give you the remainder. So if I started here and then added 5 to it, I'd start with an index of, let's see here, 0. So this would probably be 25, 24, 23. So if I started with Y, 25, 26, 27, 28. I just moved the characters around by accident. There we go. Anyway, I think it's either going to be C or D. Y, 1, 2, 3, 4, 5. So let's try Y. Did I paste that into everybody? Looks like I did. Yeah. So let's close the serial and try the letter capital Y and flash that. And then we'll see if it does indeed wrap around and give us a smaller character. Yes, it gives us D with an index of 3. And keep in mind that is 0, 1, 2, 3. So the idea is that if you divide 24, 25, 26, 27, 28, 29 by 26, you get 1 with a remainder of 3. And so it takes that remainder 0, 1, 2, 3 and throws you at the number or the letter D or the index for the letter D. See, it gives you an index of 3 and it goes and gives you a result at the string name here with the index of 3. And that is how the Caesar cipher works and how it's presented. And I know I'm going through this really fast. If you feel overwhelmed with the, with the details of the code, just keep in mind that this is meant to be covered a little more slowly and meticulously. Students will go through the step-by-step instructions, and they're not going to finish this in 3 2-hour sessions. All right, so with that, it is now 4 o'clock on the West Coast, 5 Mountain, 6 Central, 7 Eastern. Hope I got that right. So it's 0 past the hour. So let's go ahead and reconvene at 7 past the hour. Take a break, stretch your legs, use the restroom, get a drink, anything else you need.
I will keep the recording going in the meantime.
Thank you, Stephanie. And I'd better put a be back soon. So that's 7 past the hour. I'm actually going to do it at 8 past the hour. Or rather resume at 8 past the hour. All right, everyone. Are we all back? Thumbs up. Thank you, Wendy. Thomas, good job. Okay. So just a little thing on the modulus operator that gives you the remainder of a long division problem. Thank you, you others that gave me some thumbs up. I appreciate it. Okay, here is a little script that I just typed up just to clarify about the modulus operator. This was introduced way back in the calculations tutorial. So here we'll start with an index of 29 and print its value, and then take the modulus of index over 26, which is going to be 3. That'll give us our new index that took us all the way to D in the alphabet. So we'll try flashing this. So the original index was 29, and then it wraps around to 3. And that is pasted in the chat. All right, so after encrypting a single letter, we go into great detail about how it works, including an explanation of the modulus operator. So what this is showing is that, yeah, 24 over 26 is 0 with a remainder of 24. 25 over 26 is 0 with a remainder of 25. 26 over 6 is 1. And if you just take the remainder, you've wrapped around to the 0th character. And then the first character with 27, second character with 23. So this is all explained in very careful detail here inside the chapter. Okay, so encryption and decryption with the terminal. Let's try that next. There's the link to the page. And so this one does this repeatedly inside a while true loop. It asks you for a key, and then it takes that text that you typed, which goes in as a string, and then converts it from a string to an integer value and stores it in key. Then it asks you to type a letter and stores the result in letter. It converts that letter to uppercase. Remember string.upper from earlier? Well, here we have an application of it. It ensures that the program doesn't crash if you type a lowercase letter, or it doesn't tell you that it can't find the character. It goes and finds the letter. It adds the key to it. It takes the remainder of divide by 26, and then whatever that letter is, or pardon me, whatever that index is, like maybe 3, then it'll run and find your D for you, 0, 1, 2, 3, 0, 1, 2, 3, and display that. I'll go ahead and paste this into you. And do try this one. I'll go ahead and demo it while you're trying it out. Okay, so it has some sage advice here to set your keyboard to caps lock. I just closed and reopened it, make the display nice and clean. Okay, so my key if you might recall that hello was MJQQT and the key was 5. So I'll use a key of 5 and then I'll use the H from hello and I want to get an M back. Oop, capital H, be very careful there. There's the result of M. Now if we use that key of 5 and then the J from MJQQT, capital. Why is result 0? Let's try that again. Key of 5, character J. Oh, that's weird. Oh, okay. Enter the key 5, and I meant to convert E, and it's J. Now I am not sure why J. Oh, J becomes O. So if we add 5 to J, 1, 2, 3, 4, 5, we get to O. Okay, so everything still works very nicely. Do text me or give me a thumbs down or something. Oh, and thank you, JW. It's OH. And then the decryption. So if you have MJQQT and you want to convert M back to H, you can enter a key of -5. And then our J should convert back to H. MJQQT. All right, the J was the E. And then if we do M, it converts back to H. Then after doing one character at a time, we up it to entire words. And for the entire word, this is a time where we're in a loop that here's the main application loop. It's everything below and indented. But in order to do an entire word instead of a single character, we have to use a for loop. And this is a really clever little piece of Python in that you can say for letter in word. And the word is what you typed into the terminal. And it will, more modern languages automatically can say, oh, well, what they wanted us to do is take each little character from the word they entered and do them one at a time and perform everything that's below and indented from the for loop. So basically, if your word is 5 characters, it will repeat this 5 times for each character in the word and then show you the result once it's done. Here is the script for you. Okay, so I'll enter my key as 5 again. Let's see, and I think we want to use all capital letters. I don't think this one is actually converting it to fixing the case, so you definitely want to use all caps. So there's our MJQQT, and we could also do a key of -5 and then MJQQT and get back to hello. And I would like some thumbs up after you've all tried that. Thank you, Jeffrey. Excellent, Thomas. And very good. WB, way to go. Marjorie, excellent. Okay, looks like everybody's got it. So there is the first starting to get useful encryption. Now, then we can make a function out of it. We talked about functions as the kind of thing where you could have a function defined and you give it a name like Caesar, and then you can give it some parameters like key and word. And then down here, you can get the key from the terminal, type in a key, and then it converts the string to a number. And then it'll ask you for some letters. And then it will pass both the key, like the number 5, and the letters, HELLO, to this function. And this function will take care of all that converting for you and return the result. And display it for you. Sorry if I made anybody seasick with that maneuver on my screen switching. All right, so there's the latest script to try out, and it actually doesn't really differ all that much from the previous one, with the exception that it's that you can be more focused on your main code because it's doing the heavy lifting up here in the function, and so all the main code is really just down here, starting with sleep 1,000. And it simplifies things a bit. So this should work basically the same. And in this case, it does change everything to uppercase. So you could even do lowercase letters and you'd get an uppercase result. So I'll try lowercase hello. And so looks like I was wrong. Oh, no, I wasn't wrong. I just, I caused an exception because I typed hello in response to the key. If I type 5 for the key and then hello, notice I get MJQQT. If I do MJQQT, no, -5 to decrypt, and then MJQQT. And we get back to hello. So the only difference is that we're just formalizing this a little bit by making a Caesar function that accepts a key and a word and then gives you back the encrypted result. We also talk about other ciphers, like here is one where it's called the ASCII shift cipher. And what it allows you to do is use any printable character. So here's a test of the ASCII shift cipher. And you can get some pretty interesting encrypted values. It should show you the encrypted value. Okay, there's the next script to try. Let's try a key of 14. And when we type in hello, we should get different ciphertext, especially if you do it lowercase. So VSZZ, and it even has a curly brace in there just to make it complicated. And then if we do -14 and VSZZ curly brace, we can get back to lowercase hello. So this works for all printable characters and is building up towards encrypting messages to make them less sniffable on an open communication channel, which can help keep your communication private and can also help in, say, a robot race. If you're controlling a cyberbot robot using the terminal over the radio, it will also handle entering the characters and numbers and send it as a packet, whereas you wouldn't be able to do that with just a regular Caesar cipher if you're limited to only capital letters and you can't have colons and commas and etc. and the various elements of a dictionary. Did you guys get to try that? Everybody got that working? Show me some thumbs. 1, 2, 3. Oh, very good. 4. And a new message. 5, 6. All right, excellent, everyone. We're almost through encryption. See, I don't know if we want to do this one or not, or if I should just mention it. So this is a first step, and more ciphers are introduced later. And so this is a first step into what's called a substitution cipher, where your alphabet, instead of using a key and a shift, you can use an alphabet and a cryptobit. And this is the most rudimentary of cryptobits, being just the alphabet backwards. It's really not all that secure, but what that allows us to do is demonstrate some of the cat and mouse things that can go on. Now, making a custom cryptobit is something that the students do in the your turn, and they can use all printable characters, for example. Or I don't know that this is all printable characters. Yeah, we have more than this is lowercase. So the uppercase characters aren't here, and so the students can make up their own cryptobit, and then they can try that out with the countdown application and see how nicely how much more difficult to decrypt it would be if you were just monitoring a communication channel. And that's it for encryption. And so let's move on to sniffing attacks and defenses. All right, so we'll start out with just, many of the applications for the microbit have things like sharing an emoji with a friend. And so what we have in terms of sniffing attacks and defenses is that an intended receiver, you'll have a transmitter that's sending a sad face. And if it's not encrypted, the intended receiver will see the sad face, but so will somebody who's performing a sniffing attack. And so our first example is to study how, yeah, a third party can see that information, or the intended receiver can see that information, but so can the third party. So this is going to be 2 scripts. So I'll paste you in the transmitter first, and this is an unencrypted transmitter. And then we'll go and paste in the receiver script. All right, so I pasted it into the chat so you can start pasting that into your editor. And then I'll do it into my editor. Okay, and then I got to make sure both my microbits are connected here. All right. Flash. So we're going to flash both of them. And then what we'll see is that your sender microbit is not doing anything, but your receiver microbit is showing the angry and the happy, check my thumbnail, and the sad face over and over again. And that's because the sender microbit is setting its packet equal to the string happy, and then using radio send, which was introduced back in the radio, basically radio on, radio config, and setting the channel. There are 83 channels, I think. And so you can have students pair off in different channels, and then you can have even assign them in groups of 3 and have one be the intended receiver, and then the other being the sniffer. And then the students can modify this to send a particular message over and over again. And so here we can see that all 3, here I'll go and open up the terminal, and we can see that we're sending happy, sad, angry repeatedly, and that the receiver, if you think about your second microbit that's displaying these messages as if you think about that as the intended receiver, everything's great. If you think about this as the sniffing attacker, everything's not so great. But what we can do after learning how it works, which is essentially something that is included with every piece of code, is oh, okay, so we're just improving the script. I'll skip that. So we'll move on to encrypted and take a look at what happens. So we'll first take a look at what happens to the receiver if it's the sniffing attack and we have an encrypted message. So what I want you to do is just start with this sender script that I'm going to paste in. So change the sender script to this, and then take a look at what happens to your sniffing attacker first. Okay, so I'll open a serial on this one. It's still receiving the old script because I haven't flashed the new transmitter script yet. When I flash the new transmitter script, it's now, instead of sending the characters SAD, ANGRY, and HAPPY, it's sending Caesar encrypted versions of those. And look what happened over on the sniffing attacker. It received KDSSB and tried to display that, and found out that that was not one of the images that the microbit knows about. It knows about sad, angry, and happy, but there is no image called image.kdssb. So we actually are now stopped in our tracks. Now, even though we could use exception handling, I'm going to show you much more about that later. So instead of using exception handling, a sniffing attacker can, in this case, simply comment out the display.show, which is where the exception happens. And now the sniffing attacker, actually, I'm getting this way out of order. So now the sniffing attacker can see the encrypted text, but they can't actually display it on their microbit. Now, meanwhile, let's take a look at how the intended receiver will look when it's receiving these encrypted packets. And incidentally, this encryption, it's important to explain to students, look, everything that goes along the internet can be intercepted. And if it's not encrypted, they can find out things like your, whatever password to whatever social media account you're using would be available for anybody to use. Oh, sorry, I didn't paste that into the chat. Here you go. So now looking at the intended receiver with encryption, it's showing us both the encrypted version and the decrypted version. And actually, we're displaying them on both sides now, so you can see that they're both in sync. One might appear just slightly later than the other, since there's the radio transfer. Don't know if that's even going to be visible. So this is the sniffing without errors, where we commented out the display.show. And I was supposed to put a lock around that. So the idea here is that this explains that when the transmitter or the sender is sending happy, the intended receiver will see that. The sniffer will get an error, but then in the cat and mouse game of encryption and decryption and cyber attacks, the sniffer will at least figure out how to see the encrypted text, and then probably try to figure out what the decryption key is, but that would take us to brute force, and we're not quite there yet. So that's one application, the application of sharing emojis. Let's look at another application where encryption can be incorporated into the application, and that would be the texting with terminals. So to save a little bit of time, we saw texting with terminals yesterday, and you can imagine that it's the same thing where a third party could see unencrypted text. So we'll just take a look at the encrypted version today. So here is the transceiver script with, oh no, that's right. I do need to, I really want you to see the unencrypted version. Okay, so bear with me a second. Going to go to, no, not computer microbit talk. Radio basics. Texting with terminals. Okay, so we actually will start with bidirectional texts in both of them and just make sure that they're both working again. Okay, so start by putting this into both of your both of your microbits and make sure that your chat works just like it did yesterday. Oopsie. So I pasted it into the chat. So you want to paste it into both of your editors, flash both your microbits, and then open the serial connection on both your microbits. You might want to do it twice to have the screen actually clear. Or even 3 times. All right, so we can type hello and then hi, and now we know it's working fine. And the idea is that your second microbit over here, you might have a third microbit where essentially it can see both sides of the conversation. So, so a third microbit might see hello and hi, and this going back and forth conversation. Now, if we switch over to, actually, I better wait for you all to make sure you've got that tested and working. So go ahead and give me a thumb up as soon as you have it working. Mina, thank you. Thomas. Jeffrey, all right. Thank you, Bobby, for the applause as well as the confirmation. WB, good job, Anne, good job. Marjorie, excellent. So we got everybody. Looks like we've got everybody. And if I missed somebody, just give me a shout out to hold up a second. So now we're going to switch over to encrypted. And basically these checklist instructions send the students back to the previous bidirectional texts to try that out. And then to see, so basically we'd have 2 students pair off and then the third student mounting the sniffing attack, and the 2 students who are having their conversation, it'll be, you know, a seamless back and forth, but the third student will see a bunch of crazy stuff. So let's only put the encryption into one of our terminals, our transmitter, and we'll try sending a few messages here. Okay, so here's the script. And close serial. So we'll only do this on one of them. I'm going to do the first tab here. So I'll flash this, and then we'll go back to our serial monitor. Okay, so for a key, I'll just use 5. And then now everything's going to be encrypted. So if I say hello, we see MJQQT, which is familiar by now, but I figure it'll just kind of give us an example of how it's working. And the fact that we're transmitting to an intended receiver somewhere else, but the sniffing attack is mitigated with the encryption. I meant that to be a question mark. Because this gives a certain level of challenge in terms of figuring out what the encryption technique is and what the encryption key must be. Okay, everybody got that? Give me a thumb up when you've got it, when you see it when you can see from the standpoint of the sniffing attacker, the encrypted ciphertext. Good job, Sarah. Thomas, thank you. WB, good job. Jeffrey, excellent. Mina, all right. Marjorie, good job. Okay, so now let's take that same script out of our chat and change our sniffer microbit to the intended receiver microbit by simply loading in the text with encryption and decryption from your chat again. So it's just the same old, it's the same program you had in your other microbit already. So now we can flash it into this microbit. Open the serial. You got to make sure to enter the same key that you're using on your transmitter. So you want to use a key of 5. And now if you send hello and how are you today, it is seamlessly decrypted on the other end. So go ahead and give me a thumbs up when you are ready to try the next thing. And as always, questions are welcome and encouraged. Thank you, Bobby. You should encrypt that, you know. Thomas, good job. Okay, yeah, for those of you who have to leave early, do have a good rest of your day. I'll be sending the recorded veg. Thank you, WB and Jeffrey. So I'll be sending out the video so that you can see the rest of it. We'll probably make it partway into brute force attacks, and then we'll finish brute force attacks. Excellent, thank you, Marjorie. We'll finish brute. We've got another 15 minutes, but for anybody who has to bail out early, watch the video. I'll send it out as soon as I can. It's usually an hour or two, and then we'll. On Friday, we'll finish off brute force. We'll start it today, very shortly. Okay, everybody. One last example from, so we've encrypted communication so far, but you can also encrypt your application data. And since we don't have robots, I'll just show you the version for the microbit, which is using the Countdown app. And so the idea is that you'll again have a pair of microbits communicating over the radio, but you'll enter your number of seconds to count down and what to say afterwards, and that will get converted into a packet, and then the packet will get encrypted before sending it across the radio. So even though the radio channel is open for anybody to see, the data is encrypted, and then it gets decrypted by the receiver, and then the receiver application does its job. Okay, so let's see here. So let's start with let's basically, this time, since we're running short on time, let's just do the encrypted version. And then what we'll do is, so here is the transmitter. And we'll also do the receiver. I'll paste it into you and then paste it into my microbit editor. Uh-oh. Okay, the receiver is too long. What I'll have you do is I'll have all of you get your transmitter and receiver straight off the web page. So here is a link to the web page. Sorry about that. Basically, the receiver script is too long and Zoom won't accept it to chat to you. So go ahead and grab both your transmitter and receiver. And again, these are encrypted. And again, I'm just closing and reopening so we can see just the intended text. So now we can enter the countdown start and what to say afterwards. And notice that even though it's encrypted, it just behaves the same as it did when it was unencrypted from the standpoint of the from the standpoint of the user, we can't tell that it's encrypted. But to prove to yourself that it's encrypted, we can add a couple of print statements. Actually, I better let you guys all get this running. Okay, so how's everybody doing with that? Give me a thumb up when you've got it running. Good job, Mina. Okay, another early departure. It's perfectly fine. Just check the video. No problem at all. WB, good job. Thomas, good job. Okay, so let's go ahead and modify this so that we can see the encrypted text going back and forth. So I'm just going to essentially find, like on the sender, we can see that the ASCII shift function is called on line 42. So we can basically take line 37, paste it down, and paste a copy of it below line 4, between line 42 and the radio.send. And then we want to call it send encrypted. So below the ASCII shift call, you want to add a print statement that I'm chatting you right now. You're basically just printing the packet again. And on the receive end, we want to print the packet before it gets decrypted using the ASCII shift. And that is on line. So basically we want to add the print statement that's on in the receiver, we want to add the print statement that's on, actually, we want to add the same one. Just make sure it's indented at the proper level. You'll need to do that for both. You'll need to watch your indentation. Line it up with what's above and below it. So we'll add, oh no, we need to change it to receive encrypted. Okay, so right before the packet equals ASCII shift, between receiving the packet and decrypting it, we want to add the, and this is, by the way, this is an actual activity. I'm just guiding you through it, as opposed to showing you the activity. So if we flash these two, and then take a look at the serial. Okay, now if I enter the countdown start, 3, so notice that that the data we're sending before encryption is after :encrypted, start :3, but then the encrypted version of that looks like this. And then the encrypted version looks like this over here too. But then when it's decrypted, it looks like that. And so everything still works. Anybody get that running? Good job, Thomas. All right, Jeffrey. WB. Marjorie. Mina, good job. Okay. So, what we'll do on Friday is we'll start with brute force, and then we'll take a look at malformed packet attacks and defenses as well. And so what your homework will be is simply you'll get an automated, if you're not already, if you don't already have an account on learn.parallax.com, you need an educator account in order to access the assessment materials that we have published there. And so basically the way it works is if you go to learn.parallax.com, there's an educators section, and none of the assessment material, or at least none of the assessment material that students would love to get their hands on, is visible unless you're logged in, and we only give logins to teachers. So if, for example, you go to the educators section and you look at the cybersecurity for teachers, we will show you some things like a link to the student tutorials and some other relevant stuff, but and a teaching strategy guide, but we won't show you the assessment materials for download. You have to log in order to do that. And so this is the login you'll need. However, you don't strictly need this for Friday. So I'll be showing it to you on Friday. Yeah, our goal is to have everybody able to use their login. So if you already have logged into learn.parallax.com before, you already have a password, just make sure you can log in still and get to the assessment materials. If instead this is your first time at learn.parallax.com, or you have not yet gotten an educator's account at learn.parallax.com, you'll get this automated email. You'll also get an email from Stephanie Lindsay that guides you through logging in, changing your password, and checking for the assessment materials. And so that's all I want you to do as homework for Friday. But again, if you run into some kind of roadblock and we're not able to get it worked out by Friday, please don't stress about it in the least, because you won't need to be able to log in to the learn.parallax.com site in order to participate on Friday. It's not required. So that is your homework, and we are now at the 2-hour point. We'll go ahead and start with brute force, and I think I'll do some brute force and some I'll do some brute force and then some malformed packet attacks, both attacks and defenses, from examples from both of those on Friday. Then we'll have Chuck Gardner speak, and we'll talk about the rest of the material for the Friday workshop, which is going to be educator resources, upcoming workshops, how to purchase the hardware that goes with the free educational materials, questions and answers, and wrap up. Okay, you are more than welcome to stick around and talk for a little while after the recorded part of the session, which is ending now. And we'll look forward to seeing you on Friday with the same Zoom link and the same time of 3 o'clock to 5 o'clock. That's starting at 3 Pacific, 4 Mountain, 5 Central, 6 Eastern. All right, then, everybody have a good evening, and we'll see you Friday.